you're going to learn how to generate this nice smooth curve in MATLAB, the sine wave, using a few lines of code. Okay, you'll also understand exactly how to generate this and manipulate it, move it, change the resolution the way you want to by having a proper theoretical understanding of how to do a sine wave. So what exactly is a sine wave? Where does it come from? A sine wave is really a sinusoidal rotating cyclical function that goes around some radial axis, some radial direction, however many times per second. Let's say we have something that travels around here, 60 times per second. That means to make a full revolution, your vector here or arrow goes to, pi over 2 location, and then pi for a full revolution, which is 180 degrees. And it makes it all the way back to your 2 pi, its original location, in 1/60th of a second. That's what the 60 hertz is for. That's 60 revolutions per second. This translates to, if you were to map it on a graph, this thing going from here up, down, and then back to its time period where it started from. And then here you have this period that clocks in at about 1/60th of a second. Okay, and then you make that repeat however many number of times. Let's say it repeats until, for about 0.1 seconds. To plot this, that's all you have to do. You have to draw it. You have to figure conceptually how this works here, and then you have this in your y-axis, and then there's your sinusoidal waveform. Now, how do we map this onto MATLAB? Well, MATLAB needs to do things discretely in a sense. It uses arrays to calculate things in individual values. It's not like us where it can just be like, oh, I can intuitively draw this. No. What I would propose here, well, not propose, but if we take little measurements, let's say 100 of these measurements, or 1,000 or 10,000 of them, you do this in small enough resolution, it's going to look like a smooth curve. For each of these measured values from 0 to 0.1 seconds, it needs a y value for that t value. So we're going to have, say, 100 measurements in the t. We need 100 values in the y. And that's what the sine function is going to do. It says, hey, I'll take the sine of t. In fact, I'm taking the sine of omega times t. So this t right here, and this, what's this omega? This is actually going to be 2 pi times the frequency, and we'll multiply that by t. All right. So this is what we need to put into MATLAB in order for it to calculate each value of y for every value of t. So let's go ahead in MATLAB and demonstrate this. Okay, so here in MATLAB, set our t values. Our t values are going to range where we set our variable t. We say, hey, it's going to be equal to an array of values starting from 0, and the number of data points we're going to get are about, maybe 100 data points. That's way too few points, but I'm just going to show you this. And then we put another colon here, and then we say the endpoint is 0.1 seconds, just like in the drawing. Hit enter. That creates this array of values, very small number of values. So this is going to be a choppy waveform just from the beginning, like from the get. All right, now for our y, we'll say, hey, each y value is going to be equal to the sine of 2 times pi, which MATLAB knows, the frequency, which is 60 hertz, times the time t. So for every value t, we're going to calculate that y, just like we said earlier. And then we'll enter, and then we have that many number of measurements, 11 measurements. The last thing we do is we plot this. So on the x-axis will be a t value, and on the y-axis will be y. With this plot, we have our 100 measurements, and they're down here and whatnot, but this is not, the resolution's not that great. So we're going to go back and change the t values. We're going to give that way more data points. So let's say 10,000 measurements. Notice t and y are different now. If I try to plot those on the same plot, it's going to give me a problem. So I need to recalculate y, and notice that y is now 1001 points. Now I need to re-execute this plot function. Voila, now we have a very fine, smooth sinusoid, a sine wave. If we were to imagine that circle, it started at its initial point, went up, down, got to that 2 pi, and then did that a few more times, and we captured 6 cycles in 0.1 seconds. Okay, so that's how you do a sine wave in MATLAB. If you want to learn more about electrical engineering and practical skills, click on the links below and enroll in our course. Ask me questions and we'll help you get to your goal.